Okay, let's get started. Hello, everyone. Um, it's Friday again, and thank you for joining me today with TGIP. TGI Pulsar is a live streaming program that started by StreamNative. It's a weekly live stream that talk about Pulsar and its ecosystem. We would pick up topics from our daily experience on helping users adopting Pulsar. And we also have a GitHub repo for hosting all the TGIP content. So if you have any topics or any specific area you want us to share, feel free to create an issue on TGIP repo. And for people who doesn't know me, my name is CJ. I'm currently the co-founder and CEO of StreamNative. StreamNative is a San Francisco-based startup. We offer a cloud-native event streaming platform powered by Apache Pulsar, and we provide either both developer support for people who is integrating Pulsar into their architecture and offer fully managed service on helping our customer managing, installing and upgrading Pulsar installation in their environment. At the same time, I'm very excited about the work, the current work we have been working on is providing a fully hosted Stream Native cloud that would offer Pulsar as a SaaS service, and it's coming out soon. And I'm also the PMC member and of Pulsar and BookKeeper. If you have been hanging out on Pulsar GitHub or Slack, you might already know me. So if you don't know me, but you can grab CJ in the Pulsar Slack. Okay, that's me. And in this week's topic, I would like to share a bit about life cycle of a Pulsar manager. About a pulse master, it's very, I would say, based on kind of the 1 year and 1.5, 2 years experience on helping people adopting Pulsar, one of the most common questions that is coming around when using Pulsar is about how do I know what is the difference between retention and TTL, and what's the difference between backlog and storage, and why I already consume my master, but my bookies disk is still filling up. So those are kind of questions I have seen again and again, and we try our best to kind of updating parcel documentation to make sure people understand those concepts. But sometimes still, I have seen this question coming up again and again. So I would like to use this kind of episode to talk a bit about the whole life cycle of a parcel manager, so people would have an overview how a parcel manager is produced and how it is stored and how it's consumed, and then we can deep dive into kind of the storage model that Parcel is using to help people understanding a bit about the retention policy, TTL policy, and also how to read the metrics between uh, backlog storage size, and to really know why the bookie disk is still filling up, even my consumer already kind of consume a master or acknowledge a master. So let's get started. Okay, my mouse doesn't work. Okay, so just as usual, I would like to do a week in review to see what's happening in Pulsar community. And as you know, we have been doing 2.5.1 release for almost a week, and problems still coming up. This time is more about Docker building the Docker image, and hopefully that will be the last release candidate. And if you are using Pulsar and want to try to contribute to Pulsar community, I think verify release candidate is actually a great contribution to the Pulsar community. So if you are interested in contribution, I would encourage you to check out the voting thread in Pulsar mailing list and help the team verify the release candidate. And the second thing I want to share is people has been kind of using Helm as a tool for deploying Pulsar into a community's environment. And originally, the whole kind of Helm chart was not very well maintained. And besides Helm chart, we also maintain a bunch of YAML files for different community environments. And starting last week, as we are kind of proposing PIP 66 to reorganize the code structure. So we kind of remove the old Kubernetes YAML files and reorganize, enhance a bit about Helm chart. And eventually, right now, the Helm chart is kind of working great, and it also adds a bunch of the features that contribute by StreamNative. So if you are getting started with Pulsar on Kubernetes, definitely check out the Helm chart. And we have been providing very detailed documentation about Helm chart. So in Get Started, we add a section called Run Pulsar in Kubernetes. It provides a step-by-step instructions for you to get started with Pulsar in Minikube, and you're able to see install Helm chart. You're able to using Pulsar admin to create a tenant namespace in topics, and know how to configure your Pulsar client to produce messages and consume messages. And the Helm chart also install Pulsar Manager as the kind of management console. So you can also using Pulsar Manager to manage the cluster. And also it include Grafana as the dashboard. So you can use Grafana for monitoring the whole cluster. So that is get started, and that you can get started very easily, and you can do POC and verify features. But in order to uh, deploy a production grade cluster to Kubernetes, what you can do is you can follow the whole. We add a whole new section in Pulsar documentation. It's called Kubernetes Helm. So you can see here we put it as a whole section. Is we take Kubernetes deployment as a very serious consideration, and we provide all the kind of the steps like how you want to prepare your environment and how do you want to install your Helm chart. And in terms of deployment, we also provide a detailed guide how you want to configure the Helm chart to meet your requirement, from persistence, affinity to components, to TLS, and authentication and authorization. And to simplify a lot of deployment, we also provide a bunch of scripts for kind of creating JWT tokens and prepare the whole Helm release. But this just an example to give you an idea how you can configure authentication and authorization within the Helm chart. And that is a very easy for getting people started. But if you already have some sort of um, identity system, authentication or authorization system, you definitely can integrate the Helm chart with your own identity authentication authorization system. So that is Helm chart, and we also kind of want to move the Helm chart out of the main repo as a separate repo because it makes more sense for tracking all Helm changes in a different repo. And the next thing is we are going to have our monthly webinar coming up in a week also. And so Devin from Overstock will talk about the common architectural pattern in Apache Pulsar. And it's basically a production experience that Devin and his team kind of get from running Pulsar in his production. And in this presentation, he will try to cover two things. One is the high performance streaming enrichment with Apache Ignite, and the other one is how to do message tracing to trace the message flowing through Pulsar functions and as well as connectors. So that is the webinar. If you are interested in this topic, definitely sign up the webinar and hang out with him on April 28th, I believe. And that is the kind of the major items that in this week. And since this week is more about sharing a bit about the whole Pulsar Mastery life cycle, so I didn't use any kind of hands-on code instructions. Instead, I have slides I use to give presentations to people. So I will just reuse that slides to talk a bit about the whole life cycle of Pulsar Mastery. And at the end of this session, I will also share the slides in SlideShare. You can check it out. It would also available in TGIP GitHub repo for sure. And let's get started. Okay. So what exactly a mastery? When we're talking about mastery lifecycle here, is we usually talk about two things. One is how a mastery is flowing the whole system, and it is basically how the mastery is being stored. And the second question you really need to understand is the retention. In other ways, is when this mastery is deleted. So that is kind of the two main question when you're looking into using Pulsar or managing Pulsar deployment in production. Okay, let's get started in the first one. I think the first one, most of about mastery flow, you might already seen a lot of presentation online going through some of the Pulsar documentation, know a bit. And for this section, I'll probably just go quickly and walk you through some of the kind of recommendation I would have. So the first thing is a typical Pulsar installation. Usually, there might be different components, but the main two components is one is broker, and the other one is bookie. So that is so-called the multi-layer architecture. And brokers are status. The main purpose of broker is used for serving clients for producing and consuming events. So you can think about if you have a Pulsar client, a Pulsar client only deal with brokers. It doesn't talk to any other components within the Pulsar installation. And the bookies are the storage node. They are the storage node for storing data and making sure data is persistent and available for read by multiple times. So that is the storage there, what we usually call. And there's another component called BookKeeper, but BookKeeper here is mostly used for storing all the metadata of Pulsar. Those metadata including topic metadata, namespace policy, and how topic is break down into segments and where are these segments stored. So those are kind of the information has been stored in BookKeeper. Besides that, ZooKeeper is also used for service discovery within the broker cluster and as well as the bookie cluster. So broker would know the other brokers through ZooKeeper, and same thing, bookie would also know the other bookies through ZooKeeper, and broker discover bookies through ZooKeeper as well. But when we're talking about the whole the life cycle of the Pulsar master, we don't usually involve ZooKeeper because it's not even in a critical path. So we just like ignore ZooKeeper in the remaining session. So the bunch of the simple context is the entity for storing the data in Pulsar is called topic, and the topic here is a bit different from the topic in Kafka. Usually in Pulsar, the topic is a non-partition topic, so it means you usually have one partition. But Pulsar also has a concept called partition topic. It means this is a topic that has multiple partitions. So if you want to align the concepts between Pulsar and maybe Kafka, when we're talking about topic, it's more uh, close to the concept of partition in Kafka, and the partition topic is similar as the topic within Kafka. But I know it's a bit confused. So in my kind of diagram, I'll try to use topic as a partition a topic and partition as the partition. So that is kind of a common concepts that most of the people kind of already know, and we would try to use that in the whole diagrams. So you would have entity called topic for storing the data, and the producer is producing to a topic. And the master will be routed to individual partition based on the kind of a master router provided in the broker. And each partition is assigned to a broker for serving. So there's a ownership of a partition in the broker layer. And consumer is also kind of connect to the broker for consume the data. And bunch of the consumer form together as a consumer group. That is the consumer group is the concept in Kafka, but in Pulsar we call it subscription. Okay. And the first thing we need to know a bit here is how a message is flowing from producer all the way to the storage node and going back to the producer. So as you can see here is the first thing, the producer is a client instance that is created by your application, and our application would use a producer to produce a master. The master is created, and when you produce when a producer want to produce a master, there's a concept called master router, and the master router would determine which partition this master should be routed to. By default, it uses a round robin like master router. So when you try to publish the master using a producer, it will try to produce the master across the partition in a round robin way. And so when the producer select the partition to produce, it would connect to the broker who owns the master. So that is the owner broker. And once the broker receives the masters, it would actually write the master to the storage layer. And when it write the master to the storage layer, it would use the BookKeeper client, which is the client provided by BookKeeper. And when BookKeeper client write the master, it actually writes the master in parallel to multiple bookies. That is the replication algorithm that BookKeeper is using. the whole replication mechanism itself is uh, is a very interesting topic, and there's a lot of to talk there. So I'm not going to cover in this talk. But what you just need to know is on the broker side, once it receives a message, it will write messages in parallel into multiple bookies. And when the bookie receives the messages, the bookie would persist in the message, and then responds back to broker say, okay, I'm already persist this message. And once the broker receive what we call right egg column size of the response from the bookies, it would it would it will make sure the message is already persistent among majority of the bookies. So then it would respond back. So as you can see here, the produce pipeline is pretty straightforward. Is it go from a client to the owner broker, and the owner broker write to the bookies, and the bookies persistent messages and response back. So as you can see here, all the messages is actually storing in bookie in bookies, and the broker is only used for serving those produce requests. And if you understand the produce pipeline on the consume side, it's much easier. Is uh, So as you can see here is the message is stored in bookies, but it would also be cached in the broker side. So if a consumer tries to consume a message, if the message is already cached in the broker side, the consume request would the broker would just push the message directly to the consumer from the cache. So there's no additional hop that broker needs to read from bookie. So that would usually kind of map into one behavior if you are operating a parser cluster. What you usually see is most of the time you will see there's write traffic or there's inbound network traffic to the bookies, but the read traffic is relatively low because most of the consumption requests are already served by the broker. So the broker doesn't need to go back to the bookies to read. So that is the read path, is basically the consumer reading the messages from the broker. And most of the time there's no read traffic between broker and bookies. But there's a case, if you deploy an application and that application try to rewind the subscription back to maybe, for example, 3 days, that means you're starting to consume old data, and the old data is not cached in the broker, and it has to go back to the bookies to read those data. So that is the only difference between consume messages that are already cached in the broker and consume the messages that are not cached in the broker. So the only difference is basically here, the broker will read the messages from bookies and dispatch back to the consumer. So that is the kind of the whole pipeline. And I think most of the people, if you already have some idea or listen to other presentation, you might already have a clear uh, thought about this part. And I'm going to cover a bit about the kind of failure in the whole workflow. That is, the first thing is, uh, let's talk about like more from the messages flowing from producer to broker to bookies and consumed by the consumer. So on the producer side, the most of the common failure you will see in the producer side is basically uh, the producer is not able to uh, connect to a broker, or like for example, a broker is crashed, or the network between the producer and broker is disconnected. And in this way, producer is actually maintain what we call a pending queue. That is kind of keep is used for keeping all the in-flight messages. Once you have those in-flight messages kept in the queue, uh, producer would do retry if it see the connection is disconnected from the broker, and the retries can be controlled by a send timeout. If you configure send timeout to be 0, that means the producer will keep retry until success. But if you config, say, I want to wait for 30 seconds, then all the retry will happen within 30 seconds. If the producer cannot produce a messages within 30 seconds, it will just give up and drop them. It will just give up and reply to the client that I'm not able to produce to that topic. So that is the common behavior or the common failure you will see seen in the producer. But most of the time, producer is already handle those retries. So if you see like logs in your producer application, like reconnect, like a failure, and then try to look up again. Don't worry about that because that request is already retried by producer. And you have the on the client side. On the broker side is broker are mostly stateless. It didn't keep any data. So if the broker is crashed, it doesn't cause any data loss because the data is already persistent in the storage layer. And on the Bookie side is Bookie is a fully I would say is a replicate log storage. So if you just lose one Bookie, it doesn't matter because you already have other Bookies available for serving the data. So as you can see here is there's no leadership leader follower between Bookies. All same. That means the broker can read any replicas from any Bookies. So you would have a very high data availability even you are just losing one Bookie. So don't worry about that. And on the consumer side is consumer also handle retries. So you don't need to handle the logic yourself. And the only difference here is I think before 2.5, all the clients didn't retry on create producer or create consumer. That means if you're trying to create a producer at a time that your client application is not able to connect to parcel broker, you would receive an exception, and that exception you have to handle yourself. But I believe we introduced the retry logic in 2.50, so you don't need to retry anymore, and Pulsar would retry for you. Okay, that is the kind of the master flow, and I think most of the people who, if you already use Pulsar, you might already know that kind of master flow. And the most interesting part would start is talking about master retention, and that is the most confusion and most of the question I have been helping with people is more coming from master retention part. And how to set that is there's so many ways in Pulsar for you to control how mastery can be consumed and how mastery can be stored and can be deleted. And to fully leverage all these features, you really need to know like what are the difference and how to understand that and and how to better use that to calculate my storage capacity when I want to go production. So I kind of break down the things around retention into four category. One is the actual retention. That means how long the data is going to be kept. The TTL. TTL is means like how long you want a message to be consumed by a subscription. And the message backlog is how many messages that are not consumed by a subscription. And the storage size is actually what is the logical storage size that is kept by a topic. If you notice the kind of the sentence I use here is I use logical. It is because the storage size didn't doesn't reflect the actual physical storage size that you have in Bookie disk. Why? It's because there's a garbage collection mechanism in Bookies. So there's a delay between when a message is delete is marked as the delete in the broker side, the actual physical size of physical disk of that given ledger is not reclaimed until the garbage collection thread is running in the bookies. So this setting I kind of used for managing the message retention or message life cycle in different layers, and I hope in the remaining of this episode I'm able to kind of explain these concepts clearly. So first thing, in order to understanding how I would say, in order to understanding the concept of backlog and as well as TTL and retention, you really need to understanding the storage abstraction that Pulsar has. So the first thing is, I think we have been talking this quite a lot, is uh, the fundamental data structure in Pulsar is distributed log. You can, in other way, call it an event stream. So you keep appending events to log, and the log is actually the partition and the topic is using the log for storing the messages. So that is the first concept that you need to put in mind. And the second concept is you need to understand subscription. What does subscription mean? Subscription means uh, in the logs concept, it's used for tracking where you already uh, like is used for tracking uh, what is the position in this log you already consumed to. Like how many messages you already consumed, and what are the messages that you are not consumed. So a subscription is actually it's a state that it is managing the consumption state of all the consumers of a single subscription. And when it mapped to this distributed log, it's a cursor. So you can think about a subscription is a cursor. This cursor is basically mark the read position of this subscription. But the cursor within Pulsar is actually beyond a position. It actually it actually record much more information than a single position. I'll cover a bit in the later slides. So in these slides, you can see I have three subscription, and they are in different position in this kind of distributed log in this stream. And the numbers are kind of we read number. It's not, you can see it's not a kind of a simple offset number. It actually have two numbers here. Is one is called it's basically ledger ID, and the other one is entry ID. That is used for tracking which ledger you already consumed to and which entry in this ledger you already consumed to. So that is the kind of the offset concept that within Pulsar within Pulsar. So that is the subscription in Cursor. And if you understand this subscription in Cursor, you will know uh, a concept is when you start a consumer, basically like where I should start. Uh, Pulsar provide a setting called subscription initial position. That initial position would let you decide whether you want to start beginning of this stream or you want to start at the end of the stream. And what it's called the earliest position. Earliest means that you will start from the oldest master of this stream, and the latest means you will start from the newest masters of this stream. So that is the initial position. If you already have a subscription, then you try to the consumer try to connect to the broker using this subscription. Even you provide the subscription initial position, it doesn't broker doesn't take those values because you already have a subscription. That means you already have cursor in a position, so you will just restart from that position. And sometimes I say you have application you want to start from a position you would like to do, then Pulsar provide a mechanism. You can do it in the consumer API. You can also do it in the Pulsar admin API. That is, you are able to stick a subscription to a given position. And you might know the seek can be done through seek by time or seek by master ID. Those seek by time is translate into seek by master ID. Basically, what it does is it actually try to recap the masters based on the timestamp and find the master ID and do the seek based on the master ID. So fundamentally, the operation on the stream is seek by a given position. And the last operation you have on a subscription is called unsubscribe. Unsubscribe means you delete the cursor on the stream. Why I spend so much time on talking about cursor here is actually in order to understand master retention, you need to really have this concept about stream and cursor. Why? Let's get started with a few examples. So this is a stream, a topic with two subscriptions. And one subscription is consumed to the position of 2.2. And subscription C is already consumed to 3.2. That is two different positions. And that, for sure, there are two different cursors. But when you map to this whole concept, that means beyond the messages before 2.2 means it's already consumed by both subscription B and subscription C. Those are the messages are okay to be deleted. But the messages after 2.2, that is some of the subscription is not consumed or not did not consume those messages. So that means those messages are not okay to delete. And in the portion of the okay to delete, if you apply master retention there, that means if you say I want to keep if I configure master retention, say 100 megabytes, and what it does is it will make sure even those messages are okay to be deleted. Those messages are already consumed by these two subscriptions, but they'll be kept for a while to meet the retention policy. and before they can be deleted. That means in the purple area, those messages are not okay to delete because the message retention would keep this message around for a given time before they can actually be deleted. So that is the message retention. And till this point, you would know message retention only apply to the messages that are already consumed by all the subscriptions. So even you say I config, give a random example. If I config the message retention to be 1 day, and I have two subscription, they haven't consumed any messages for 7 days. Those 7 days message will be kept and they will never be deleted. It's because these two subscription has a cursor in this log, and because of the existence of this cursor, and Pulsar will not delete any data, even they already out of date. So with that being said, if you want to configure message retention, you need to realize the message retention only apply to all the messages that are already consumed and acknowledged by all the subscriptions of this topic. So that is the first concept you need to have in the mind. Uh, the the second part is, let's take a bit deep dive into the portion that are not okay to delete. In other way, I would actually using a term to call these messages is yet to be processed. That means some of the messages might already be processed by all the subscriptions, but some of the messages are not. So there's a so if you want to understanding the other concepts, then we need to deep dive into this portion, the kind of the orange portion. You need to understanding how the other policy play around this portion. So I kind of convert this kind of high level overview into a more concrete example. Is just lay out a display log with 11 messages, and to keep things simple, I would just use green as an indicator that all the green messages are already acknowledged by any of the subscriptions. And for the orange one is they are the unacted messages. They might be already acknowledged by some subscription, but to simplify the whole conversation, I just mark these messages as all unacted messages. So that means in the green area is you would have they're already acknowledged, and but some of the messages you can delete for sure, and some of the messages might or still be kept around due to retention policy. And the yellow, so the orange part is the messages are not acknowledged or even not delivered to the users, so what we call yet to be processed. Then you need to the next concept you need to understand is the message expiry. If you're coming from a Kafka world, or you have a lot of knowledge around Kafka, you know retention sometimes is kind of tied to message expiry. Because Kafka would delete the message if you configure a time-based retention. But message expiry here in Pulsar is a bit different. That means for a given subscription, the messages are expired and not be able to consumed by a subscription. So that is the TTL concept that we have in Pulsar. And so you can see here, TTL is only applied to the messages that are not uh, not acknowledged. So that means if the message is already acknowledged, there's no TTL doesn't play here. Only retention and other mechanism play there. So TTL only kind of apply to the those unacted messages. So if you already configure a TTL, that means uh, uh, Pulsar didn't delete any messages if you those messages already passed the TTL duration. But what it does is actually just moving a cursor around. That means for this example is if we say I config TTL to be 1 minute and I have an egg message from 9 to 15, and if after 1 minute if messages 13 from 13 to 15 are already expired, sorry, from 9 to 12 are already expired, that means Pulsar will move a cursor to mark these messages as automatically acknowledged. And once this message marked as automatically acknowledged, then the retention policy would kick in. So with that being said, the TTL mechanism in Pulsar, I usually call it a mechanism to automatically acknowledge messages within a subscription. And the benefits for that is Pulsar is pure a subscription, a cursor-based system. So if you have a service on application, the consumers of that subscription might be going offline for a duration, but during this duration, your cursor will never move because you are not able to receive any acknowledgement coming from the consumer. But this means this subscription will keep these messages forever. And sometimes you don't want this happen, then you need to add a TTL to this topic to automatically expire, automatically moving the cursor to based on the time. So you don't into a situation that you have subscription that you might not be using for for duration, then this subscription just keep the data forever. So that is the mastery expiry part. And if you understanding this part is the retention control applied to the mastery that are already acknowledged, and TTL apply to the messages that are not acknowledged. And TTL provide a mechanism for moving the cursor to to convert or mark the message, mark those unacted messages as act, so that retention can kick in and recycle those data. So that is the relationship between retention and TTL. And if you want to really mirror the behavior as what you get from Kafka, is you can configure TTL to be exactly same as your retention. And that is exactly the behavior you can get from Kafka. So that is the message retention side. Then understanding that, after understanding that, the next question you want to answer yourself is, what is backlog? Backlog is usually means for a given subscription, the messages that this subscription has not processed, that it might already receive the messages, but uh, uh, the subscription hasn't complete its processing and never acknowledged back to the those messages. It also includes messages not dispatched from broker to the consumer. So basically, it's the all the messages newer than the cursor position. So that is a simple way to define the backlog. And the backlog right now, it's more about number of messages. It's not about size or it's not about time. And I believe there's some discussion around that to provide um, time-based backlog, or in other way called lag. I think lag is a concept coming from Kafka word, is for measuring how far you are behind, how far a consumer is behind a producer. So that is another way to kind of talk about that. But as you can see, each subscription would has its own backlog. And this backlog is measure like how many messages that this subscription is not yet processed. But if you use topic stats, you will also see there's a backlog uh, metrics field in the topic stats. That is the topic backlog. Topic backlog means you can think about it's the maximum backlog across all the subscriptions. So that is the backlog part. So you have now you're understanding the difference between retention and TTL, and you have the idea about backlog. Then the next thing you really need to understand is when the message is got deleted. As we can as we so that is the green area that we looked before. Is basically all the messages are already acknowledged, but some of the messages are kind of kept around due to retention policy, and some of the messages are saved to be deleted because they are expired. But what exactly Pulsar would how exactly Pulsar delete those messages? So that kind of to understand that behavior, you need to go back a bit about the storage, the fundamental abstraction of the storage. So within Pulsar, a stream or a log is kind of divided into multiple segments, and this segment is so it organizes the message in segments, and segments is stored as a ledger in BookKeeper, or in the tier storage is actually a new blob. So as you can see here, is the messages actually organized in organized and stored in segments. So when deletion happen, so for this example, you might say from the retention you already config is 10, 10 to 15 should be kept by retention, and 5 to 9 should be deleted. But in reality is message 8 to 10 are kind of stored as part of segment 2. And the funny thing here is we don't delete individual messages within a segment. Instead, all the deletion happen on a segment level. We delete the messages segment by segment. So even from retention perspective, 8 and 9 might already expire, but they could not be deleted. So in this way, it means these messages would be kept around until the last messages in this segment is expired. So this would to understand this is some I have been talking to a bunch of I've been helping with some people before, and people will think I already acknowledge, and why my segment is still kept around, why I still be able to receive the first message I produce. That is just because uh, you acknowledge the message, but it doesn't mean this segment is deleted. The segment is only deleted when you broke a row over into next segment, and the previous segment is all the messages in previous segment is expired. So that is kind of the unexpected behavior that you would get from Pulsar. So to really understand this part would help you understanding about the storage usage that you would expect from Pulsar. So if you understand this concept, then it's easier to understand the storage size. The storage size is basically, it's very simple here, is it makes sure all the storage are copied by the undelete segment in bytes. That means uh, the storage size doesn't mean the whole messages that kind of kept around by the retention policy, but it means all uh, the total size of the undelete segment. So if in this case the segment 2, 3, 4 are kept around, so the total storage size actually the total size of these three segments. So that is the storage size. So sometimes you will see a gap between uh, if all your subscription already delete the messages, already acknowledge the messages, and you don't config retention. So you would expect, say, storage size to be 0, but sometimes you will see, oh, it's about like 100 megabytes. And why? It's just because there's still all the acknowledged messages are in the active segment, and the active segment will never be deleted. It will only be deleted is when it roll over into the next segment, and the previous segment will be deleted. So you usually will see this gap there. So just to be clear when you see this behavior happen. So to kind of recap this, is the message deletion is happening like segment by segment. But there's also a disconnection between the storage size with the actual disk that you used on the Bookie side. What's that? Is even the broker delete a segment, it didn't reclaim the whole disk space that used by this segment immediately when it's deleted. There's a delay between that. Is deletion is only remove the metadata, so it means this segment is gone from the system, but the actual disk of this segment is reclaimed by a garbage collector that is running in each bookie's background. And when this garbage collection happening, it's actually controlled by a parameter called GC wait time. So the garbage collector is basically wake up every GC wait time and then check if there are segments deleted. If there are segments deleted, and I would reclaim the disk space. So sometimes you will see you might have a topic that already copy 100 gigabytes, and you run topic delete, and you find why my bookie still have 100 gigabytes. It's just because the garbage collection is not kicking, and so you would see the disk space would maintain in 100 gigabytes, and at some point you will see it drop to 0. So that is the behavior you will see from some of the monitoring metrics from Bookie side. So to recap, that is there's a couple settings when you want to kind of configure your system to able to have enough disk space to support your workload. You really need to know from logical application setting perspective to your system setting. So first thing is more from the application perspective, from the user perspective. We need to know how much data you want to keep, and do I need to apply TTL to my subscription to prevent any subscription going down to cause the message cannot be cleaned up clearly. So those are the settings called retention and TTL, and it's available in both broker and namespace. So you can configure this based in per namespace perspective. The next thing is if you configure retention, you really need to know is when I can trigger the message to be deleted. And that is controlled by the ledger rollover time. And ledger rollover is basically how what is the size of the of each segment, and what is the maximum time I need to wait before rollover to a new ledger, what is the minimum time. To control that, you would know when this message retention would be triggered. And the last thing is, uh, if you already configure your user settings, you configure the broker to delete the messages when later roll over. But the last piece you want to set here is you want to making sure you have the right bookie settings to making sure the garbage collection kick in time. So then it can remove or reclaim the disk space for those deleted segments. So usually you want to align the GC wait time along with this minimum or max lateral over time to making sure GC doesn't wake up to garbage collect nothing, or GC collector doesn't wake up or doesn't wait too long to garbage collect those segments. So you want to align these two settings together to making sure the bookie can garbage collect the segments quickly. And there's a minor tweak there is around compaction. Uh, why there's a compaction concept in the bookie is because ledgers are interleaved stored in the entry log, and some of the ledger might be long-lived ledger, some of the ledger might be short-lived ledgers. And in order to reclaim some of the disk space used by those short-lived ledgers, you need to tweak these compaction settings to make sure it's able to compact the entry log to reclaim the disk space copied by the short-lived ledgers. So those are kind of the settings. And I know it's a bit hard to tweak around these settings, and I have been helping people on this tune these settings. So if you have any questions, if you have any um, production that would require tune those settings, feel free to reach out to me, and I'm happy to help as well. And I think that is the whole episode for this week, and I hope that is very useful to you guys, because I think it's very useful, especially if you want to operate Pulsar in production. Those are the concepts from an operator perspective you really need to know and really need to understand them well. And hope if you have any feedback, feel free to give to us. And that would be the whole presentation for this episode. And and if you enjoy the whole like TGIP, please subscribe to our YouTube channel. If you have any good ideas, create issues for us, and we would like to share any topics that can help people run Pulsar and manage Pulsar very well. And thank you for our time. Thank you for hanging out with me online, and enjoy your rest of the day of Friday, and have a great weekend. and see you in the next episode. Bye bye.